Hello everybody, today we'll be doing sort colors. Given an array of nums with n objects colored red, white, and blue, sort them in place. So that objects of the same color are adjacent with the colors in the order red, white, and blue. We will use the integers 0, 1, and 2 to represent colors red, white, and blue respectively. You must solve the problem without using the library sort function. Okay, so we have first a couple cases, happy cases, here and here. An edge case would probably be like a single item because that's the only thing that is different. So, I mean, that's the minimum number. And there's no sorting to be done, basically. We just do nothing. Okay, so those are all the cases because all numbers can only be 0, 1, and 2. And let's get started with the time and space complexity. It's going to be O of n and O of 1 because, well, you want to come up with a constant space and you want to use, you need to go through an entire array. So that's going to be why it's going to be the time and space complexity is going to be, time is O of n and space is going to be O of 1. Okay, so let's match. What are we matching here? What sort of things that can we do with space is a pointer system. We can only use pointers because when we're doing O of 1, we're not doing anything new. So here's the plan. What we're going to do is, let's say we have I and j, or just, yeah, like I and j. And we can do this multiple passes. So how this works is that we just move the j forward until we see a 0, and then we swap it with the I. So 0 and 2. And now we move the I forward. We just take the j, go to the end, and we swap it with the I again. Now we have all the zeros in place. We move I forward, and once j hits the end, it will become I again. And we'll move the j forward, and we have I. We swap that, and we move the I forward. We swap that, and we move the j I forward. And now j, then we're done. Yeah, but that's 2 passes, and what we want to do is a single pass. So that means we need a third variable to get this done. So what we're going to do is have an I, we have to bring it all back. And that means we need a third variable. So we have I and j at the same spot, and we have a k at the end. What happens with k is that with j, if we see that, that means we have places to put items that we haven't had before. So j, if j is equal to 2, so we can set that equal to 2, and minus equals 1 for k. Now we look at j again. It is 0, so basically swap with itself, and we're good. Swap with itself again, we're good. Now we're still moving j forward because j is the place where we are going to store all the zeros. I mean, I is the place where we're going to put all the zeros. So, and now we move forward again. J is now 2, so we swap it with k. So this is going to be 1, this is going to be 2, and then we move k down. We don't know what we've swapped with k, and it could be 2, so that's why we're going to keep j at the same spot. Lastly, we see that j is 1, so we just move forward. We don't need to, j is where all the 1s are going to be. I is where all zeros are going to be, and where k is going to be is where all the 2s are going to be. And now, once j is greater or is equal to k, we know for sure that we have done everything we needed to do, and we have done it in one pass. Basically, we have only gone over all these items once. Though, of course, what happened here was that we go over the items from both ends. Though we do both go from both ends, we did only do one pass. So that is the plan, is to create 3 pointers. And I, j, and k. Set I at 0, k at end, and j at 0. We're gonna, if j is equal to a 0, then swap with I and increment both I and j. If j is equal to 1, then increment j. And if j is equal to 2, then swap with k, and we're going to swap with k and decrement k. We're not going to increment j because we don't know what we have just swapped in. We could have just swapped in 2, and that means we have to swap j again. With that, as long as j is less than k. Yeah, that's it. That's the plan. So let's get started. Let's implement the plan. We might need to improve the wording a little bit later, but let's just keep it the way it is, because j is 0, I is 0, k is going to be length of nums minus 1. So while j is less than k, if j is equal to 0, nums j, sorry, is equal to 0, then we're going to do a swap. So nums at I and nums at j are going to be equal to nums at j and nums at I plus equals 1, j plus equals 1. Else if nums at j is equal to 1, then then we just move forward. Then j plus equals 1. Else, that means the only possibility is a 2. Let's just label that just for completeness sake. And I like that as well. So what we're going to do is swap j and k, because we want to move all the 2's to the end, and that's what we're going to do. And then we're going to increment k only because we don't know what we have swapped into j. And that's it. That's all we need to do. With that, I think we can run the code and do our review. Looks like we have an issue here because, let's see, out of range. Out of range. Let's take a look at that. I'm not sure what happened here, but j is out of range. Wow, I really don't know what's going on. Let's print j and let's see what's going on. Zero, 0, 1, 2. Well, 2 is definitely not out of range, but apparently k is out of range. Oh, I see why. Because we did not decrement, we incremented instead. Okay, so run the code again. It looks like our answer is accepted. And let's run our base cases. I mean, not edge cases, sorry, edge cases. Oh, we have a wrong answer. Okay, let me know why I have the wrong answer. So this is incorrect. I want to know why it's incorrect. So maybe we have to set. Let's just check it out. Let's see what's going on here. I thought we got it all cleared up. I and j, and it's not. And we have something to learn, which is also good. So we have j is equal to 2, so we swap with k. So we have 1 and 2, that's great. So we move the k down, and we see j is 1. Now j is equal to k, and less than or equal to k. We want it to go past, and so now j swaps with I, so 0, 1, and now j go passes k, and we are good to go. I think that's better. Let's run this code again. Oh shoot, we have a whole bunch of stuff here, and we have just let's run those test cases one more time. I think this time we are good to go, and we have an accepted solution. Let's submit and see what happens. It might be wrong, it might be right, we don't know, but it is right this time, so that's good. And we have completed the squirt color problem in O of n time and O of 1 space with 1 pass. So O of n time in 1 pass of all nums, and we had O of 1 because we did not only used pointers. So with that, we have completed our problem, and that's all, right? Can we do this better? Because this looks and reads pretty poorly. I, J, and K. Like, the next reader of this code will know nothing what I'm talking about according to the problem that we're trying to do. So what we're going to do is that we're going to change all the I's into red. And we're going to turn all the J's into blues. And then we're turning all the K's into whites. And it looks like I missed a couple. Okay, so I hope that reads a little bit better. Let's run it to make sure it's still working, and I didn't write any typos in here. And we did, and we did. We missed one. And we also missed another one. I don't like how blue is worded, but those are where, this is the pointer where all the blues will be, and red is where all the reds will be, and where the white is where all the whites will be. So that's how the that's how the cookie crumbles. Do you think the reader will see this code properly the next time we go through this code? I think they will still have to run through the code in their and to find out why we only move the red and the blue together in sync. We still have to find out why we're moving the blue and why we're decrementing the white. Maybe a couple comments. We only move the red to where all zeros are. We only move the white to where all the 2's are. We ignore all the 1's. And we want to do this problem, solve this problem in 1 pass. So we will be going from both ends. So with that, we can say we are moving all the items to where the zeros to where I is. We're moving all the 2's to where K is, and we're leaving all the 1's alone. So that's it. I hope you learned something today. And if you have some better code, better way of representing this, please post it in the comments so we can all learn together. If you enjoyed this video, like and subscribe. If you want more videos, check the link in the description below. Thank you very much, and I'll see you in the next one.